Hi, so right now we're going to talk about factoring perfect square trinomials into difference of squares. So these are about pattern recognition, period. That's it. We're just looking for a certain pattern, and if we see it, then it's a, oh, I know how to factor it kind of moment. Okay. So first of all, we have to figure out what those patterns are. So perfect square trinomial. What that means is it's a trinomial. So the three terms that factor into a binomial squared, right? So that's the perfect square part. Okay. So to find the pattern, what I like to do is take students back to the multiplying section. So let's say I have x plus 3 quantity squared. What does that look like when I factor it out? What does the perfect square trinomial look like? This is the factored form, but what does it look like when it's all multiplied out? So let's see, we'd get, right, x plus 3 times x plus 3. So we get x squared plus 3x plus 3x, so 6x, and then plus 9. Okay. What about this one? X minus 4 times x minus 4. So x squared minus 4x minus 4x minus 8x plus 16. X minus 5 times x minus 5. X squared minus 10x plus 25. In fact, can we just write down x plus 6 quantity squared? Do you see what that pattern is coming out the other side? Right, x squared plus 2 times x times 6, so that's 12x, right? That comes from the, up here, it came from the minus 5x minus 5x. Altogether I have 2 of those, so 10, negative 10x. So 2 of the 6x's, and then always a plus 36, plus the last thing squared. Okay, so first term squared, so 3x quantity squared, I'll do that right here, right, from our exponent lesson. Right, we square the 3, we square the x, so 9x squared plus middle term 2 times the 3x times the 7. So 2 times 3 is 6, times 7 is 42x, and then plus the 7 squared. Okay. If it's a plus b squared, this is a big pattern. I'm going to put a big box around it. A squared plus 2 times a times b plus b squared. Okay. Your life will be much easier later if you know that pattern, the squaring a binomial pattern. Okay. So some things you might notice. The constant term in all of these is a perfect square, and it's always positive. The first term in all of these is also a perfect square, always positive. And then the middle term, well, there's not really much of a pattern other than it's even. Okay, so we could say it's even. The pattern that that exists between the b and the middle term, we'll discuss that more too. Okay, so warm up. Are these potential perfect square trinomials? Okay, so on the first one, positive perfect square. That's good. Check. First of all, trinomial. Check. Even. Check. Perfect square. Check. Yep. Potential. I don't know for sure, but you know, it's not out of the running yet. Okay, what does that next one look like? X squared plus 10x plus 25. Let's see. Trinomial. Yep. Perfect square. Yep. Positive. Yep. Even. Yep. Perfect square. Yep. Potential. Right? It's worth the time to investigate to see if it is. Okay. Did you go through the check on this one? All right, that one's right, possibly. 4, I have a trinomial, check. I have a perfect square, check. Oh, but it's negative. Nope. Right? No chance that that can be a perfect square trinomial because the constant term's negative. So I'm not even going to look. Let's see, number 5, trinomial, check. Perfect square, check. 9 is a perfect square and y is a perfect square. They're together. Right, so that would be 3y squared. So that's right, that's what that would be. So check. Positive, check. Even, check. Perfect square, check. Yep. Okay, so 4 yeses and a no as far as potential. Okay, now if they are perfect square trinomials, let's go ahead and see. So those ones that we put yep on, let's see. It's like, okay, well, is it? Does it factor into something squared? So if it does, then we know right away, right, how to fill in your binomial squared. The first spot has to be, right, the square root, right, or whatever you have to square to get the first term. Right, so 9x squared is 3x quantity squared. So that would go in the first spot. The middle term's positive, so I'll put a plus in the middle. And then I'd need the square root of 4 is 2, because 2 squared gives me 4. Okay, so this would be my guess. So factoring perfect square trinomials is kind of like a guess check. First we decide if it's worth our time to guess, and it was on this one, so we guessed this. Is it? So now we'll check. So 9x squared, yep. 4, yep. And do I get 20? Do I get 20x if I take 2 times 3x times 2? Is that equal to 20x? Okay, back up here for the middle term, right? We're squaring a binomial. That middle term, 2 times a times b. 2 times a, 3x, times b, 2. Does that give me 20x? What do I get? I get 6 times 2 is 12x. Oh, shucks. Nope. All right, it was a good guess, but it's not. So maybe it factors a different way, and we would use an AC method next, okay, just to see. Number 2, it's a yep, so let's see. Something squared. What times what to get? X squared. That'll be an x. My 10's positive, so that's what goes in the middle here. Square root of 25 is 5. Check. So let's see. X squared. 2 times x times 5. Does that give me 10x? Yep. And 5 squared, 25. All right. Hey, it was 1. Right? Okay. What's going to go in my binomial squared down here? 49x squared. What is that as one term squared? Right? 7x. 7x, if I square that whole thing, I get the 49x squared. And then, all right, a plus again, and that would be a 9, or square root of 9 is a 3. So this is our guess. And now we're going to check. We're going to check the middle term. Right? 2 times 7x times 3. Is that 42x? I know you can't even see the 42. That's okay. 2 times 7 is 14. 14 times 3 is 42 times x. It worked. Yay! So 7x plus 3 quantity squared is how this thing factors. Perfect square trinomial. Okay, this one 4 isn't a perfect square trinomial, so we're not even going to try doing it that way. It might factor using an AC method. 5. Oh gosh. Okay. So when we go to factor, so I know right here was my reasoning before, so it'll be a 3y last. These are all positive. It doesn't have to be positive. They can be negative. So plus 3y squared. And then what would go in the first spot so that when it's squared, it gives me 4x squared? Okay, so 2x. So this is our guess. So we'll check the middle term. 2 times 2x times 3y. Is that 24xy? 2 times 2 is 4 times 3 is 12xy. Oh, nope, not big enough. It was a good guess, but that's not it either. Okay, so that's how we factor perfect square trinomials. The other pattern we're going to look for is difference of squares. Okay, so the difference, subtraction, and squares, right, your perfect squares. So both terms have to be squares. And I said both. Oh my gosh. So difference of squares is for two terms. This is for binomial. We're going to learn how to factor three different binomials, right? Special patterns. So binomial difference means we have to have a subtraction, and they both need to be squared. Okay, the pattern is a squared minus b squared. Okay, and if it is a squared minus b squared, that always factors the same way. So just to review, right, remember back the multiplying. Do you remember what we called these in chapter 4? Same two terms, right, in both sets, but I changed the sign. Right, these are the conjugates. And what happened when we multiplied conjugates together? Right, we get x squared minus x, here in the middle, plus x, minus 1. The plus x and the minus x add away, and we just get x squared minus 1. Well, hey, right, perfect square, subtraction, perfect square. Even when they're a little bit uglier, right, it still works. So 3x times 3x will be 9x squared plus 6x minus 6x minus 4. So the 6x and the minus 6x add away, and we just get 9x squared minus 4. Two terms, both perfect squares, minus in the middle. Okay, so these are the patterns we're looking, and when we see them, they will factor like their left sides. Okay, so number 1, are these difference of squares? Do they fit the pattern? So first things first, two terms, check. Subtraction, check. Both perfect squares, check. So yep. How would this one factor? X squared minus 16. Right, x plus 4 times x minus 4. Okay, or likewise, x minus 4 times x plus 4. Either way. Number 2, 49x squared plus 1. Difference of squares. Let's see. Two terms. Check. Oh, it's a plus. It's a sum. Nope. I don't even have to worry. They're both perfect squares, so that's great, but the fact that it's adding in the middle doesn't help us. We can't write this as two binomials multiplying, right? Anything we're going to try is going to have that middle term. Okay, number 3, difference of squares. Well, I have a perfect square here, and I have a minus sign, but I also have 3 terms, so that makes this a no right away. Okay. Now, number 4 is kind of tricky because it's not x squared here in the first, it's x to the 4th, but x to the 4th, as we know from chapter 4, is x squared squared. So it is a perfect square. It is a minus 2 terms. That's a perfect square. Okay, so this one does factor. And we're going to practice it down below on number 2. So let's go ahead and see how you would factor that one, because it has a trick at the end. So x squared plus 1 times x squared minus 1. Okay, it's not a trick, it's a oh. Okay. So this is a true statement. X to the 4th minus 1 does factor to x squared plus 1 times x squared minus 1. However, that x squared minus 1 breaks down again because it's another difference of squares. It's kind of like when you're prime factoring whole numbers and right, you have to look back and say, oh, am I done? Do I have all primes, or does it factor some more? Okay, so this one factors some more. First one doesn't. Can't do anything else with an x squared plus 1 because it's the plus. But x squared minus 1 would be x plus 1 times x minus 1. Okay, and those 3 factors you can write in any order. It doesn't matter. Okay, so practice factoring. I have 4. Okay. So which one of the 2 patterns we talked about today are these going to fit into, or is it something else entirely? 2 terms, which means if it's anything we know yet, it would be a difference of squares. So does it fit that? Square minus square, yep. Right, so it factors into those conjugates, and it's 2x and 3, and then one's plus and one's minus. 2, hey, here's another one of those x to the fourths. All right, so we'll remember that's x squared plus 9 times x squared minus 9. And really, every time we write down an x squared or an x to a higher power, we should ask ourselves, well, can I factor that any farther? All right, so x squared plus 9, the answer is no because of the plus. X squared minus 9, the answer is yes. Yes, we can. So x plus 3 times x minus 3. Notice I'm doing my multiplying by just putting them next to each other. Right, sometimes they get a little spread out, but okay, 2 more. X squared plus 12x plus 36. So it's not a difference of squares because I have too many terms. So maybe it's perfect square trinomial. So we guess. Well, okay, we should take a look. I know because it's in the section. But 36 is a perfect square. It's positive. I have 3 terms. X squared, perfect square. So our guess would be an x. The 12x is positive, so that goes here. Square root of 36 is 6. This is our guess. And then we check the middle term. 2 times x times 6, does that give me my 12x? It does. So that is how they factor. And the last one, x squared minus 36. Difference of squares, indeed. X plus 6 times x minus 6. Okay, so that is a special pattern, 2 special patterns you should be on the lookout for.